This is Honors Algebra 2 Pre-Calculus. We're doing section 9.1 from Pre-Calc, which is sequences and series. So previously we've talked about explicit formulae for an nth term, right? So a sub n written in terms of n. Now what we're going to talk about is a different kind of formula. This is called a recursive formula. It uses one or more of the previous terms to generate the next term. So the most famous example of this is something called the Fibonacci sequence, which we're going to do an example for. If you're into cool math stuff, you should definitely check out Vi Hart on either the Khan Academy site or on YouTube. She does some really great videos about how Fibonacci shows up in nature. Fibonacci sequence is super dope, and it shows up in everything from plants to animals to star systems to everything. It's kind of ridiculous. So you should check it out. She does a much better job than I would, so definitely just go see it. So in example 4, we have essentially a recursive formula. So in a recursive formula, you're going to be given some of the terms. Now here they actually started at the 0th term, a sub 0, instead of a sub 1, and that's fine. So we're given the first two terms, 1, and then the next term is a 1. But then what we're given is for any value after n is 2 and later, so this is when n is 0 and n is 1, and this would be any value after that, a sub n is the sum of the term before a sub n, right? The term right before a sub n would be a sub n minus 1. For instance, if it were a sub 2 minus 1 would be a sub 1, meaning the one right before it. And a sub n minus 2 is the one before that, right? So here's how it looks, right? So we know that a sub 0 was 1, and a sub 1 is 1, right? But based on this rule right here, a sub 2 should be a sub 2 minus 1, which is a 1, plus a sub 2 minus 2, which is a 0. Well, that's just these two terms, right? So this next term, this term right here, is just the sum of these two, right? It would be 1 plus 1, which would give us a 2, right? And then when I go to find the next term, right, the next term, a sub 3, should be a sub 3 minus 1, which would be a 2, plus a sub 3 minus 2, which is a 1. Well, look, that's just the two terms that came right before a sub 3. So that is going to end up being this 2 plus a 1, which would be a 3, right? So just like I used these two terms to get the 2, I used these two terms to get a 3, right? And then if I wanted a sub 4, right, a sub 4 would be a sub 3, because that would be a 4 minus 1, plus a sub 2. Well, look, that's just the two terms that came right before it, right? Here's a sub 4, here's a sub 2 and 3. So that's going to end up being a sub 3, which was a 3, plus a sub 2, which was a 2. So it was the sum of these two terms, which gave me a 5, right? So I end up with terms 1, 1, 2, 3, 5. And if I want the next one, right, if I wanted a sub 5, I'd get a sub 4 plus a sub 3, right? Well, a sub 4 was a 5, right? And a sub 3 was a 3, so I'm going to end up getting that these guys sum, when I add the 2 that came right before it, 2 and 8. Now, that's going to keep on going forever, right? So forever and ever and ever. So just to be clear, what happens is my sequence looks like this. 1, 1, those are the ones I was given. The next one is 1 plus 1, which gave me 2. The next one was 1 plus 2, which gave me 3. The next one was 2 plus 3, which gave me 5. The next one was 3 plus 5, which gave me 8. And I could keep going, and it's actually much easier to see once you get the pattern here, because the next one, right, so to get the next term, I would do 5 plus 8, and it would give me a 13, right? And then I would do 8 plus 13, and it would give me a 21, dot, dot, dot. I can keep going like this forever. The next one's 34, right? In fact, my AP Calc kids gave me a really great birthday card and a great birthday party on my 34th birthday, but my next birthday is not till 55, which is sad, right? So I've got a long ways to go till I get my next birthday, but at 34, it was dope. So, anywho, point being, this is the Fibonacci sequence, and this is a recursive formula. That's how you generate it. Now, what I want you to notice about a recursive formula is they can be kind of annoying, because with an explicit formula, like we saw in examples 1, 2, and 3, in an explicit formula, if I wanted the nth term, right, if I want the 200th term, all I have to do is plug in 200 for n, and I get the 200th term. But here, if I wanted the 200th term, I would have to find all the terms up to 200. I'd need a sub 6, a sub 7, a sub 8, a sub 9, a sub 10, a sub 11, you get the gist, all the way until I get to a sub 198, a sub 199, and then boom, I can get a sub 200. So an explicit formula lets you find the value of any a sub n, but a recursive one requires that you use the previous terms to find the new one, which can be a lot longer and more drawn out. So again, this is the Fibonacci sequence. It is a recursive formula. We'll do more examples in a sec.